Connecting the four number 4 conductors together with a split bolt is a sound practice. The grounding electrodes, which are the rods, provide a path for fault currents to flow safely back to the neutral. By connecting all 4 electrodes together, a redundant path is ensured for these currents to travel. This reduces the risk of electrical shock or fire in the event of a ground fault. The National Electrical Code, or NEC, requires that all grounding electrodes be connected together with at least one number 4 copper conductor. By tying the 4 number 4 conductors together, this requirement is met. When multiple grounding electrodes are connected together, the overall resistance of the grounding system is reduced. This improves the system's ability to dissipate fault currents and maintain a safe voltage potential. To do it, firstly, use a split bolt that is rated for number 4 copper conductors. Secondly, strip about 1/2 inch of insulation from the end of each number 4 conductor. Thirdly, connect the 4 conductors to the split bolt and tighten it down securely. Fourthly, protect the connection with electrical tape or a waterproof sealant. It is important to ensure that the number 4 conductors are properly sized for the amperage of the panels. This type of grounding system is sometimes referred to as a parallel grounding system. The inspector is correct in requesting that the number 4 conductors be tied together. Grounding and bonding are critical for electrical safety. The primary purpose of grounding is to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers and fuses, clearing the fault quickly and safely. Bonding, on the other hand, connects all non-current carrying metallic parts to create an electrically continuous path, ensuring that there are no voltage differences between them. This reduces the risk of electric shock if someone touches 2 different metallic parts simultaneously. The NEC, or National Electrical Code, provides specific requirements for grounding and bonding to ensure electrical safety. Article 250 covers grounding and bonding requirements. For grounding electrodes, the NEC specifies that a grounding electrode system must be established. This system typically includes a metal underground water pipe, a ground ring, rod and pipe electrodes, and other listed electrodes. If a metal underground water pipe is used as a grounding electrode, it must be supplemented by an additional electrode, such as a ground rod or ground ring. Ground rods must be at least 8 feet long and driven at least 8 feet into the earth. The NEC also specifies the size of the grounding electrode conductor, which connects the grounding electrode to the equipment grounding bus in the service panel. The size of this conductor is based on the size of the service entrance conductors. For bonding, the NEC requires that all non-current carrying metal pots such as metal enclosures, metal raceways, and metal equipment frames be bonded together to form an electrically continuous path. This bonding is achieved using bonding jumpers, which are conductors that connect the metal parts together. The size of the bonding jumpers is based on the size of the circuit conductors. The NEC also addresses the bonding of interior metal water piping systems. These systems must be bonded to the grounding electrode system to ensure that they are at the same electrical potential as the other grounded parts of the electrical system. This bonding is typically achieved by connecting a bonding jumper from the metal water pipe to the grounding electrode conductor or the equipment grounding bus. It is important to follow the NEC requirements for grounding and bonding to ensure electrical safety. Improper grounding and bonding can create hazardous conditions that can lead to electric shock or fire. Number 4 copper conductors are often used for grounding and bonding due to their ampacity and durability. The ampacity of a number 4 copper conductor depends on its insulation type and installation conditions, but it is generally rated for at least 70 amps. This ampacity is sufficient for many grounding and bonding applications in residential and commercial electrical systems. Split bolt connectors are commonly used to connect grounding and bonding conductors. These connectors provide a reliable and secure connection that can withstand the stresses of electrical systems. When using split bolt connectors, it is important to ensure that the conductors are properly stripped and inserted into the connector and that the connector is tightened to the proper torque. The grounding electrode system should have a resistance to earth of 25 ohms or less. If the resistance is higher than 25 ohms, an additional grounding electrode may be required. Grounding and bonding are critical for the proper operation of overcurrent protective devices, such as circuit breakers and fuses. These devices are designed to trip and interrupt the flow of current in the event of a fault. However, they can only operate properly if there is a low impedance path for the fault current to return to the source. Grounding and bonding provide this low impedance path, allowing the overcurrent protective devices to clear the fault quickly and safely. The NEC also addresses the grounding and bonding of separately derived systems such as generators and transformers. These systems must be grounded and bonded in accordance with the NEC requirements to ensure electrical safety. In addition to the NEC requirements, there may be local codes and regulations that govern grounding and bonding. It is important to check with the local electrical inspector to determine if there are any additional requirements that must be followed. Regular inspections of grounding and bonding systems are important to ensure that they are in good condition and are functioning properly. Inspections should include checking the condition of grounding electrodes, grounding electrode conductors, bonding jumpers, and connections. If any problems are found, they should be corrected immediately. Grounding and bonding are essential for electrical safety. By following the NEC requirements and performing regular inspections, electrical systems can be protected from the hazards of electric shock and fire. The grounding electrode conductor connects the grounding electrode to the neutral bus in the service panel. The size of this conductor is based on the size of the service entrance conductors, as specified in NEC Table 250.66. The equipment grounding conductor, or EG, provides a path for fault current to return to the source from non-current carrying metal parts. The size of this conductor is based on the size of the circuit conductors, as specified in NEC Table 250.122. Bonding jumpers are used to connect non-current carrying metal parts together to create an electrically continuous path. The size of these jumpers is based on the size of the circuit conductors, as specified in NEC Table 250.102. When installing grounding and bonding conductors, it is important to avoid sharp bends and kinks, as these can increase the impedance of the path. Conductors should be installed in a neat and workmanlike manner. The NEC requires that grounding and bonding connections be made using listed connectors and fittings. These connectors and fittings are designed to provide a reliable and secure connection that can withstand the stresses of electrical systems. When making grounding and bonding connections, it is important to ensure that the surfaces are clean and free of corrosion. Corrosion can increase the impedance of the connection and reduce its effectiveness. Antioxidant compounds can be used to prevent corrosion. The NEC also addresses the grounding and bonding of specific types of equipment, such as swimming pools, spas, and hot tubs. These areas require special grounding and bonding considerations to protect against electric shock hazards. Ground fault circuit interrupters, or GFCIs, are required in many locations to protect against electric shock hazards. GFCIs monitor the current flowing in the circuit and trip if they detect a difference of 5 mA or more between the outgoing and return current. This difference indicates that current is leaking to ground, which could be a sign of an electric shock hazard. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be properly grounded and bonded to ensure that they function properly. It is important to consult with a qualified electrician when designing and installing grounding and bonding systems. A qualified electrician can ensure that the system meets all applicable codes and regulations and that it is installed in a safe and effective manner. Regular maintenance of grounding and bonding systems is important to ensure that they continue to function properly over time. Maintenance should include checking the condition of grounding electrodes, grounding electrode conductors, bonding jumpers, and connections. If any problems are found, they should be corrected immediately. Grounding and bonding are not the same thing, although the terms are often used interchangeably. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting non-current carrying metal parts together. Both grounding and bonding are essential for electrical safety. Static electricity can build up on non-conductive surfaces and discharge to grounded objects. This discharge can be annoying or even harmful to sensitive electronic equipment. Grounding and bonding can help to reduce the buildup of static electricity and prevent these discharges. In some cases, it may be necessary to use special grounding techniques to control static electricity, such as static dissipative flooring or grounding wrist straps. The NEC provides specific requirements for the grounding and bonding of data processing equipment. This equipment is often sensitive to voltage fluctuations and electrical noise, so it is important to ensure that it is properly grounded and bonded. Isolated ground receptacles are sometimes used to reduce electrical noise in sensitive electronic equipment. These receptacles have a separate grounding conductor that is isolated from the normal equipment grounding conductor. The isolated ground conductor provides a dedicated path for noise currents to return to the source, preventing them from interfering with the operation of the equipment. It is important to follow the manufacturer's instructions when installing and using isolated ground receptacles. The NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. This listing ensures that the equipment has been tested and meets certain safety standards. When purchasing electrical equipment, it is important to look for the UL listing mark or other recognized testing laboratory mark. Electrical systems should be inspected regularly by a qualified electrician to ensure that they are in good condition and are functioning properly. Inspections should include checking the condition of wiring, outlets, switches, circuit breakers, and grounding and bonding systems. If any problems are found, they should be corrected immediately. The NEC is updated every 3 years. It is important to stay up to date on the latest NEC requirements to ensure that electrical systems are installed and maintained in accordance with the latest safety standards. Continuing education courses are available for electricians and other electrical professionals to help them stay up to date on the NEC and other electrical topics. These courses can provide valuable information on the latest codes, standards, and best practices. Electrical safety is everyone's responsibility. By following safe electrical practices and maintaining electrical systems properly, the risk of electric shock and fire can be reduced. Always turn off the power before working on electrical equipment. Use properly insulated tools and equipment. Never overload electrical circuits. Replace damaged wiring and equipment. Call a qualified electrician for any electrical work that you are not comfortable doing yourself. Grounding and bonding are essential components of a safe electrical system. Proper grounding and bonding help to protect people from electric shock, prevent fires, and ensure the proper operation of electrical equipment. Always follow the NEC requirements and consult with a qualified electrician to ensure that electrical systems are installed and maintained in a safe and effective manner. If unsure about any aspect of grounding and bonding, seek professional guidance to ensure safety and compliance. Remember to prioritize safety when working with electricity and to always follow the applicable codes and regulations. Electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. Proper grounding and bonding are crucial for creating a safe electrical environment.